Hi everyone, welcome to this session on atomic structure. Everything around us is made up of matter. Atoms are the building blocks of matter. Atoms can be found all around us. They are in our bodies, the soil, water, air, and the foods we eat. Did you know that apples which have sugars would have the atoms carbon, hydrogen, and oxygen? The iron we get from dark leafy vegetables is also made up of atoms. An atom is the smallest part of an element that can exist and still maintain the chemical properties of it. Outside of the atoms that were mentioned earlier, can you think of any? In one of our previous videos, we looked at the definition of an element. Can you recall what an element is? They are pure substances. They can be divided into two main groups, metals and nonmetals. Just as how you have a name, each element has a name and can be identified by atomic symbols. The periodic table of elements has a list of the names of the elements discovered along with their symbols. An atom of each element comes with two numbers. These numbers represent the subatomic particles. The subatomic particles that make up an atom of each element are protons, neutrons, and electrons. The center of an atom is called a nucleus. The subatomic particles that can be found in the nucleus of an atom are called protons and neutrons. These particles are collectively known as nucleons. Most of the mass of the atom would be found here in the nucleus of the atom. Electrons orbit the nucleus on what is known as shells or energy levels. Most of the atom is an empty space. The movement of the electrons around the nucleus constitutes the volume of the atom. On your periodic table, you will see something looking like this for each atom of an element. This is referred to as a nuclear notation. X represents the atomic symbol, A represents the mass number, and Z represents the atomic number. Nuclear notation can be used to calculate the subatomic particles. The letter Z or Z, which is the atomic number, represents two subatomic particles. And these are electrons as well as the protons. The mass number represents the nucleon number. This is the total number of protons and neutrons in the nucleus of the atom. The number of neutrons can be calculated by subtracting the atomic number, which is also the proton number, from the mass number. Let us look at the nuclear notation for the element Li, which is lithium. The mass number for lithium is 7, the atomic number is 3. This means that the proton number for lithium would be 3 and the electron number would also be 3. The number of neutrons in lithium can be calculated by subtracting 3, which is the atomic number, and also the proton number, from 7, which is the mass number. This would result in 4. Let us look at beryllium, which is Be. The mass number on beryllium is 9, the atomic number is 4. This means the number of electrons would be 4, as well as the number of protons. The number of neutrons can be calculated by subtracting 4, which is the atomic number, also proton number, from 9, which is the mass number, to give you 5. So the number of neutrons would be 5. You can try this one on your own by using the nuclear notation of fluorine to identify the subatomic particles that makes it up. When you calculate your subatomic particles, they can be used to draw what we refer to as shell diagrams. The protons and neutrons are placed in the nucleus of the atom. The electrons are placed on shells. Beryllium has 4 electrons. 2 electrons are placed on the first shell and 2 are placed on the second shell. Fluorine has 9 protons and 10 neutrons, which are placed in the nucleus of the atom. The 9 electrons are placed on shells orbiting the nucleus of the atom. It is important that you understand how to arrange the electrons on shells. The electronic configuration is used to represent the arrangement of electrons on shells in an atom. Each shell can hold a maximum number of electrons. Since we'll be looking at the first 20 elements at this level in chemistry, we'll be using the guide in the blue box outlined. The first shell will hold a maximum of 2 electrons. The second shell will hold a maximum of 8 electrons. The third shell will have a max of 8, and the fourth shell a maximum of 2 electrons. Beryllium, which has 4 electrons, would have the electronic configuration 2-2. 2 electrons would be placed on the first shell and 2 electrons on the second shell. Fluorine, which has 9 electrons, would have the electronic configuration 2-7. 2 electrons will be placed on the first shell and 7 electrons on the second shell. For revision, try this table on your own. Use the information from the previous table completed to draw shell diagrams for oxygen, silicon, and potassium. Thanks for watching and listening. I will see you in the next session.